Okay, so so for example, I'm going to turn off the quadratic here for a bit. That's a linear function right there, right? Have a degree of 1. So the leading coefficient, right, would be right in front of x here. And I have a slider here for the leading coefficient. So obviously it will affect how steep or shallow basically the line is, depending on if the value is greater, it's going to be a steeper, right? Your slope is steeper. If it's getting closer to 0, it's going to flatten out until you get to exactly 0. But then when it turns negative, it's going to point downward, right? You always read a graph from left to right. So this is a linear, okay? Let's turn that one off. Apple Pencil here, there we go. And then let's turn on the quadratic right here. If I were to change A, I just want you to basically pay attention to the sign, okay? So if A is positive, the parabola is going to be opening up, right? It's going to be pointing up. What is if I asked you for the end behavior for this one, what would you say? End behavior, I'm asking you where do the ends, where are they going to end up? And here you would say quadrant 2 to quadrant 1, right? So that's basically what I'm asking you here. Is it wrong to say quadrant 1 to quadrant 2? No, you still get the marks for that. I just need to have Q1, Q2 there, okay? If the leading coefficient is negative, it's going to be pointing down. And in this case, it's going to be quadrant 3 to quadrant 4, or 4 to 3, right? So that's another thing to remember. So just by looking at the leading coefficient, you can tell what it is. B, how does B affect my parabola? It will affect it, like B shifts it sideways a little bit. And C shifts it up or down. So we're going to talk about that in a little while as well. C is essentially the y-intercept if you think about it. So you're basically moving the y-intercept up or down depending on what the C value is. So A is important in terms of the sign, and C is important in terms of the shifting that happens vertically. Okay? Let's turn that one off, and I'm actually going to take you to a different one. The cubic. This one is new to you. I have so many here, I just need to make sure I find it. I had it ready to go here. Cubic. Does this look like a cubic function to you? Doesn't it look like a parabola? Yes, it does. What's A equal to right now? It's 0. So you're basically turning off the cubic part of it, and you're just turning it into a quadratic if you do that, right? So as soon as A is on, that is a very classic view. Let me just zoom in a little bit here. That is a very classic view of a cubic. It does the bending, okay? However, it may have no bends in it. So how does A affect it? Right now, what's the end behavior for this one? A is positive, so Q3 to Q1, right? It's the same as a linear, okay? It's the same as a linear. When we had a positive A value, leading coefficient for a linear, it behaved the same way. So the ends end up in the same. It doesn't do the same in the middle, but nonetheless, it does have that. So watch this bend here. B will kind of affect it, right? It can make it very pronounced or hardly noticeable, okay? As well as the C value. So I'm going to go back to the notes in a bit, but cubic may have no turns, 0. This one doesn't have a single turn. You're just sliding down the slide, right, or going up the slide. But it can then turn into 2 turns. So it has either 0 turns or 2 turns. Okay, that's the cool part about a cubic. And so, what do you think this is going to be found? That point is going to be important to us. This is what we used to call the vertex on a parabola, right? We don't have the highest point, but we still use max to access this point, and guess what we're going to use for this one? The min. Okay, so that's still going to stay the same. And so if I turn a negative, watch what's going to happen. It's going to do this. It's similar to a linear. A linear, when it's a negative leading coefficient, it does the same thing. So the end behavior is the same. Okay, and then C will affect the bend. Okay, so it can be very sharp. So sometimes it depends on the situation. You'll have a greater C value, right? Or it can actually bend the other way. It actually becomes straight, almost a straight line, but it's just a very smooth curve at that point. And this one is important. What do you think is going to happen if I shift D? What's going to happen to the graph? It shifts it up and down, just like it. So that last, remember this, the last constant there, that number at the end, always produces a vertical shift, okay, when we talk in polynomials. So that's also another important thing to keep in mind, okay? So if you want to make note of that, that's probably a good idea. So if you go to page 6 in your booklet, this is reviewing, unfortunately it's not as interactive, right? But if we have a negative leading coefficient for the cubic, right, for the cubic and the linear, you have the same end behavior, okay? If you have a positive leading coefficient for the linear and the cubic, they have the same. So the ends end up in the same quadrants, okay? That's something very important to remember. We're not going to go there in this course, but just so you know, any odd degree function will have the same end behavior, okay? So let's say we went quintic functions, which you're not going to see. It would look different. It would be weird in the middle, but the ends would end up in the same quadrants, okay? Same with even degree functions. So the parabola is kind of lonely here, right? But if we did a quartic, like a power of 4, a degree of 4, it would behave similar to quadratic. So even powers have the same end behavior. Odd powers have the same end behavior. So that's kind of like a nice pattern to remember, okay? So come with me here. I'm going to find a blank page. So I have a lot of practice graphing pieces here. I want you to go to 17 with me. 17. So I need you to kind of be able to imagine or kind of picture in your head what the graph may look like. Okay? So let's go to 17. And then we're going to practice that on the boards a little bit. I'm just going to give you random examples. So let's say here, sketch the graph. So sketch is just honestly no points, right? We're just going to make it have the characteristics show up. A function with a degree of 2, you know that it's a parabola. Right? A positive leading coefficient, now we know more. Now we know it's going to do this. And has one x-intercept. Just one x-intercept. So you have options here. If this is your x and y axis, just like that. Doesn't have to be pretty. If it has one x-intercept, it means that the vertex is right on the x-axis, and then it goes up from there. Okay, that's all I would want you to do there. Or if you did it again, right, it doesn't matter if the parabola is on this side and then you graph it like that, that's fine as well. Okay. So if I asked you to do that, that's all I would, so it's not very specific, so you can just leave it like that, but that follows all the requirements. What about this? Sorry, if I asked you for end behavior, what would it be? Q2 to Q1, right? So you got to imagine this arm would keep extending until it ends up ultimately in Q2. So Q2 to Q1 is what the province would expect you to answer there. Oftentimes they do multiple choice on these ones, like the end behavior for the following function is this. Sometimes you have to just state it. Okay. What about the next one? The next one I want you to sketch has a degree of 3, goes from quadrant 2 to quadrant 4, has 0 turns, and 1 x-intercept. How would we do that? So start with, and I'm going to tell you this, we may have different sketches. If I ask you to do this on a test or a quiz, okay, that's fine. So if it goes from quadrant 2 to quadrant 4, we know that this is Q2 and this is Q4. So we want the ends to go from here to here. And you want 0 turns. So all you need to do here is imagine a slide like this. Just give it a little bit of a bend. So this has no turn. I shouldn't be seeing a turn. And does it fulfill the requirement of 1 x-intercept? It does. It just crosses it once. How many are possible for a cubic? How many are possible? The degree tells you. A cubic has a degree of 3, so it has up to 3 x-intercepts possible. A quadratic, degree of 2, up to 2 possible. Okay, so that's for you to maybe add to your study sheet. I will give you a little bit more down the road. I know it's a little overwhelming here. The course is designed assuming you've taken grade 11 applied. So if you haven't seen some of this stuff, then obviously it's going to be a different story. So the next one, you want a cubic, also a degree of 3, 2 x-intercepts, 2 turns, goes from Q3 to Q1. Let's try that. How many turns does a cubic have? Do you remember? You should probably have that. It's either 0 or 2. That's all, right? There's either no turn or 2 turns. So Q3 to Q1, this is Q1 here. This is Q3. So I know it's going to go from here to here, okay? Which means the leading coefficient is positive, correct? 2 turns. You got to be careful here. You only want 2 x-intercepts. So 2 turns means you're going to want something like this. Right? There's a turn there, there's a turn there. If you make the turn look like this, you're going to have how many x-intercepts? 3, correct? So I'm going to move this up a little bit. I'm going to move this up so that I'm going to make it go through here and through here. That's just an example, right? So I'll kind of do this. I'll make it cross here and then turn like that and then go up like that. And erasing is fine. Okay. This one has 3 x-intercepts. So you got to watch out for that. Because if we brought this down a little bit, then all of a sudden this would loop underneath, and then you would have 2 x-intercepts at this point, so that would add up to 3 in total. Okay. All right. Let me try something here. We're gonna now put a little bit of a break on this. I just wanted you to kind of try it out. And we're gonna go back to graphing. So let's go to 9. I am assuming you at least gave this an honest attempt. Okay, page 9. So I'm going to do a quadratic and a cubic with you. and then you can you're gonna have a little bit of time to try some questions today. Okay, so let's type this in all together. Even if you've done this already, let's do this all together, because if there are things I need to highlight, you should have the same thing. This is negative 0.067 x squared, yeah, plus 48.197x. You type it in exactly the way you see it. The province will do 3 decimal places sometimes, maybe even 4. Okay, but don't let that throw you off. You have a calculator to do this. You may ask, what is this? Don't worry about that too much. Okay. Sometimes I use it, sometimes I don't. I'm gonna do without this time. What do we know about this one? It has a degree of 2. It's a quadratic, because I want you to be able to see right away when you're confronted with a formula, it's like, or a function. What is this? The leading coefficient is what? Is negative. So what do I expect? Which way is this going to go, up or down? It's going to point down. The legs are going to go down. Okay, so all of these things you already know. What's the y-intercept? 85. Okay, 0, 85. So I think it would be fair to say that these things you should be able to figure out without the calculator, just like that. So let's graph this now. Okay, so I see one of the legs here. I'm going to get rid of y2 equal to 0 for now, because some of you haven't seen this. So I see this leg, so I expect it to do something like this. Change only one thing at a time. I'm going to try to find my vertex. So I'm going to increase, I'm going to go to window, I'm going to increase y max to something. Let's try 100. Why 100? I don't know, I'm just trying here. I still need more. I'm going to be a bit more aggressive now. I'm going to go 500. I'm just making sure I typed it in right. Okay, let's keep going up a bit more. Let's try 1,000. So it's going this way, okay? So I'm going to go x max. I'm going to increase x max to see more this way. I want to kind of chase the equation, the parabola. I'm going to go 100 for x max. Okay. Still not working for me. So I'm going to go 500 for x max. Still not coming down, right? I'm going to try 1,000 for x max. There I see the other leg coming down, okay? So don't do too many things at a time. You kind of chase your curve. Now I'm going to increase my y max a bit more. Anybody tried it already? I'm going to go 5,000 here. Go big or go home. 10,000? There we go. 10,000 works. Okay. So a lot of graph window, graph window, graph window until you find something that works. How do you know this is a good window? You see the x-intercepts, you see the vertex, and the y-intercepts as well, the x-intercept here. Perhaps I should go a little bit further. Just make sure you follow. Make sure you go y-min. I'm going to go negative. Yeah, it's probably a good idea to see a bit more in the negatives here. Yeah, so you clearly see your x-axis. Everything is there. What do you need for a graph? Vertex, intercepts, must. Okay, you're listening to this? Vertex, high and low points, because cubic is going to have high, low points. Okay, and so you just get it that way. So let's find it. The vertex, I'm going to go second trace. What are we going to use for this? Which function? Second trace. We're going to have to use max, because that's our max up there. Okay, that's the highest part. So this is what I require you to do. Just go second trace max. If you're going to complain about keystrokes, we can make you do this by hand. I don't think you would appreciate that, right? So this is the minimum I'm asking you to do. So then you need to find a left boundary to the vertex. So you got to go to the left, arrow to the side. So right, left movement here, not up and down. Enter. You hit enter. Then it's asking you for the right boundary. It just means that you're going to go to the right of the vertex. Hit enter. And when it says guess, you hit enter one more time. And there is your vertex. So it's 359.70, no, sorry, 68. And it's 8,752.73. Very important to have on there. The x-intercepts. There are two. How do we find them? We let y2 equal to 0. And you go second, trace, intersect. So you go to y equals, go to y2. It should be a red line. If somebody else messed with your colors, you can change the colors. You can actually go to the color, hit enter, and pick the color of your choice. I will keep it at red. So y2 is equal to 0. That's a horizontal line you're graphing along the x-axis. I'm going to find this intersection first. Second, trace, intersect, or press 5. Oh, it's closer to this one, so just go arrow sideways and travel a little closer to it. That's good enough. And then hit enter 3 times. Does that ring a bell from last year? I hope so. 721.12. I do this one more time. Second trace 5. Use the cursor to go all the way around. Closer to that point. And then hit enter 3 times. So the first one was 721.12, right? And the second is going to be negative 1.760. There you have it. Okay, I found it with the calculator. So I have vertex, I have the x-intercept, and I have the y-intercept. Let's say you forget that that is the y-intercept. This is what you can use, because you're going to need it for the other functions. Second trace value, and you let x equal to 0. So if you go second trace value, let x equal to 0, there it is, it's 85. So you found it using the calculator. These are the points you must have on there. Okay, let's graph it now. You need to have arrowheads on your axes, okay? And then label x and y. And now you need to determine a scale that's going to work for you. I look at my x. Let's look at the x-axis first. I need to go all the way out to 721 positive, okay? And so I need to make sure that works out. So I'm going to go 100. No, that's not going to work, right? I need to go 200 at a time. Yeah. 200, 400, 600, 800. Okay, so make sure you use those boxes and they're equally spaced out. Make sure you make a mark telling me where the number is supposed to go. And I'm going to do, just to be consistent, I'm going to do the same thing going to the left, to the negatives. So that's going to work for those. I can plot them already. Negative 1.71 is so close to the origin there. You plot that one. Plot the 721. 700 is going to be right in between 6 and 800. So 721 is just a little off to the right. Close enough is good enough. That's our saying and applied. Okay. 0.85. That's my y-intercept. So my y-intercept goes to 85, but my vertex goes even higher to 8,700. See that? So I'm going to go 2,000, 4,000, 6,000. That's a little tight still. 2,500 maybe, or 3,000. You could do 3,000. I'm going to go, I know my key is different, okay? That's fine. My key is probably different. But just to show you that it doesn't matter, as long as you're consistent with your scale, I'm going to go negative 2,500, negative 5,000, equally spaced out, same increase or decrease. Okay? That is a consistent scale. That's what we're talking about. Let's plot it. So I'm in the 360s. This is 300, 360 is right about there. And I'm going to go all the way up to 8,000, 25, so 12, so right about, let me just, yeah, right about there. And so now you've got your x-intercept. Let's do the y-intercept. That is going to be really hard to plot correctly, but it's very close to the origin here. Just go out and over through those and make sure you keep extending out. You don't want a V at the vertex. And just make sure you add your equation, negative 0.067 x squared. And there you have it. So thanks to the x-intercepts and the vertex, we were able to kind of find a scale that would work for this particular case. Okay. All right, let's do a cubic. That one is new to you. So let's go to page 10. And then I'm going to ask you to try at least 2 in class. I'm going to actually give you some class time so that I can come and see you and maybe address some of the issues that arise. Okay. So we know that the degree is 3. We know that this is a cubic for that reason. That's the name of this function. It's a cubic. When it has a degree of 3, it's a cubic. We know that the y-intercept is going to be 0, negative 20. We know that the leading coefficient is negative. So what does that mean? Think of a linear function. When you think of cubic, think of linear. We know it does something like this. Okay? It's going to go from quadrant 2 to quadrant 4. However, ours is going to probably do a bend. Okay? Ours is going to do a bend, maybe a turn. A bend for sure. The turn, it depends on what you see on your calculator. That I wouldn't require you to figure that out without graphing it on your calculator, okay? Chances are, listen carefully to this part, if the x squared or the x term is there, it's going to have a turn, more than likely. If you see only the x cubed, nothing else, maybe just a constant, it's not going to have a turn, okay? No turns. So, grab your calculator. This is when you have a fraction here, I use brackets to enter those. So I go bracket, negative 4 over 3, close the bracket. And then I go x cubed. So this is the annoying part about this calculator. It doesn't have an x3 button, so you have to use this hat here. Look up here on the screen. My finger is right on it, the hat button. And then go 3, but watch out. You gotta go arrow sideways to come back down. Okay, you want the cursor to come back down. Otherwise, you're gonna add to the exponent. You don't want that. Plus 15x minus 20. I'm gonna let y2 stay 0, okay, because we're gonna come back and get it. So let's graph this now. And what I'm going to do is, this window that we just had was a very extreme window, okay? So how do you reset your window? Zoom standard. There it is. I can see a lot of it. What should we change here in terms of the window? Y min, right? Let's go to Y min. And let's go, what, negative 50? It's a pretty good graph. How many x-intercepts do you think this has? One for sure, right? Yeah. You have a different window, different graph. The graph looks different. So let me check if I made a mistake first before I come and see you. Oh yeah. Oops. See, I'm showing you what not to do. Yes, my bad. That's a good catch. Okay, let's try this again. Graph. So I need to now change my, I'm going to reset this, okay? Zoom standard. And we know that it's coming from here, turning up and then back down. We know that that's what's happening here. So window, let's do Y min first. I'm going to go negative 20. Very close. I'm going to go a little lower. Negative 30 maybe. There we go. So we see the first turn. And we're now going to chase the other part of this graph. I'm going to go window, Y max, 50. I'm going to try 50. Let's see what that does. Not good enough. Y max, let's do 150. Let's go more aggressive, 500. There we go. 500, now I see the upper turn, so I saw this turn. Guys, if there's a turn, if you see one turn, you know that there's going to be another one. If it has a turn, it has two turns. Okay? So turn, turn. Let's go a little bit further on the X max. 50 is probably overkill. Let's try 20. There we go. And let's go just a little further down on the Y min, just to have a nice, you want a bit of a frame around your graph. There we go. That is more likely. So we have three x-intercepts here. And we've got the high and the low here. So we're going to find all of those. Okay? I will do this. You know, the official name for max in this case is local max. Because this thing doesn't truly have a max, like the highest point ever. Because it actually keeps on going indefinitely. So this is a local max and a local min. Okay? Let's do the local max here where my pencil is. How would we access that? Second, trace, max, and my cursor is already close to it. What does it ask you for? A left boundary. So hit enter. It is perfect right there. Travel over it. So you come down, enter, enter one more time. 7.5, right? 7.5, 261.25. I went second, trace, max. Now we're going to find the local min. So we don't have vertex, right? We just have local min, local max. So second, trace, minimum. Here is the minimum where my pencil is. You need to go to the left of it. Enter. To the right of it. Enter, and then enter one more time. What's this? That's 0. See that? E to the negative 6. This is actually 0. It's right on the, so we're going to go 0, negative 20. So my local min is also the y-intercept. So sometimes that happens. Okay. And now let's find the x-intercepts. We're going to go y2 is equal to 0. Second, trace 5. I already let my y2 equal to 0. I hit graph. Second, trace 5. Go to the left one here. enter, enter, enter. The first one is negative 1.10, 0. The next one is just further to the right. That one is 1.22, positive, 0. Second trace 5. One more time. Enter, enter, enter. That's 11.13. There you have it. So you've got local max, local min, which is technically the quote-unquote vertex that we used to deal with in our parabolas. You've got all x-intercepts. You also have the y-intercept. It's here, and we also knew anyways that that was our y-intercept. Okay, let's graph it. And then we're starting word problems after this. Not today necessarily, but that's what's coming next, okay? So y and x. A good scale here. I don't need to go too crazy with my x values because I go from negative 1 to 11. But make sure you leave some room to go beyond it. So how about if I go 5, 10, 15, I'm going to go by 5s. And I go negative 5 here. So that's going to be okay for my x-intercepts. My local min is 0, negative 20. So I can do the same here. I'm just going to go by 5s. Oh yeah, that's right. I would have eventually found out. Right? The problem is if I go by 5s here, then my local max is 261. It doesn't fit. So you need to address that. So what would work? 50? No. Let's go by 100. 100, 200, 300. Okay. And yes, that's a good catch. You cannot have a different scale under the x-axis and then a different one above it. It just doesn't work. They're very picky with that. Okay. So let's plot everything now. 0, negative 20 would be, this is 20, 40, 60, 80. Yeah, so this is actually right there. 0, negative 20 is right there. So if you can be accurate, if you can be precise, then be precise. Local max is at 7.5. So 7.5 is right here. And you're going to go all the way to 261. Somewhere there. Okay, so that's my local min, my local max. And now I'm going to plot all of my intercepts. So this is negative 1.1. This is 1.22. And then I've got 11.13 right there. And have this as your model, right? You have that to help you out. So you're gonna come down here through the local min, through your x-intercepts. You go to the local max, and then you come down to the x-intercepts. And then from there on, you want to continue with the same trajectory and just go further out. And here, you kind of also want to make sure this doesn't cave in. Okay, that is what my graph looks like. If you used a different scale, yours might be a bit stretched out, flatter, it doesn't matter. Just be consistent with your scale. And don't forget your function, okay? Most of the time the province gives you a grid. I've seen every year, but every time I say every time, it bites. So I'm going to say we're not sure, but most of the time they give us a grid. And just use a ruler to make your markings if you need to make those. So this is how you do a cubic. Okay. So I'm gonna pause here. I need you to try it yourselves. So I'm gonna say this. we're gonna try, just circle with me, follow me through, because there's a bunch of, I have a lot. If you're done all of them, you keep going, okay? I'm gonna say on page 11, circle question 2. That's it for that. Keep going. Then we're gonna go to the quadratics. I'm gonna ask you to do question 2 there as well. No, we're gonna go to page 14 where we do question 3. My bad. I want one that's a little wider. That one is gonna be hard for you to find your window. So 14, question 3, right? Keep going. Then we get into the cubic. Let me just double check. I want you to have one that is doable. We're gonna go with 8 on page 16. So here it is one more time. I'm going to write it down here. Page 11, question 2. Page 14, question 3. And page 16, question 8. Okay, those are the 3 that I would like you to try. So it's a linear, a quadratic, and a cubic for you to try. All right. So you graph it on the grid that I provided, and I would like you to all work on this. Okay. And if you are done, right? If you are done all of it, I'm going to post a key where you see the keys to every single one. So if you want to keep trying, you keep trying. You should not have an excuse not to be working, okay? All right.